Hello everyone. Today I'm going to show you our project DNA computing model for SAT problem. So this project has been made by me, Muhammad Jamshid Ghaffar and Muhammad Sami Amjad. So the core components are it's capable to parse conjunctive normal form, and how it does it creates the DNA strands and solves the problem by simulating the DNA computing. So that's our whole concept, that we can solve the satisfiability problems with the help of DNA computing, and we are simulating that. So it's a fully fledged simulator that can simulate the CNF and solve the problem and give us whether the solution exists or not. So this is the architecture. It consists of 5 steps. First we have a decoder module which decodes it, and then we create the population. Then this is an iterative step. In this step we apply the clauses, we filter out the clauses which are not satisfying, and we keep on repeating this again and again until we run out of all the clauses, and then we verify that whether a solution is really satisfiable or not, and after that we show the results. So these are 5 steps. This is the same as I show you, and this is a web-based simulator. So let me show you our web-based simulator. So this is a web-based simulator. You can go to the site websimulator.versal.app, and here you can simulate it as well. Like we have this CNF problem, you can run the simulation. Let's see. Yes, so I have run the simulation and it's showing that how many steps it took to give me the solution. So it took 9 steps, and you can see how it uh, how it come to the final answer. So it's showing that first it filtered the clause, and then it does the amplification. Amplification is necessary because you run out of strands, so you need to amplify the strands, so you have sufficient strands so you can do the next iteration. So it after 9 iterations we get the solution, and we have 3 satisfiable solutions. And we can also run this simulator in a Python. So we have this GitHub based project which you can clone. You can clone this project. So yeah, this is a GitHub project. You can clone our project and you can install it, and this is the examples how you can run it. So let's see. Let's run an example here. So I have already created all the setup, so let's run the example. Say, yeah, so this is the example one. We have this clause, and through the DNA simulation it have found these are the 2 satisfying solutions. So it's showing the time it took to found the solution, and how the initial population, how many in population it has in the final result, and it's showing whether it's satisfiable or not. So in the next example it's showing that it's not satisfiable, as we know that the solution of this problem does not exist. And similarly we have some other examples, and we have also verified with the brute force in order to show you that it's really showing you the exact solution. So that's all. This is our project, and you can actually clone the project, and we have really nice documentation as well. Like so this is our API. You can use our API to actually run the simulation. So you just have to import these modules, and you have to set the configurations, and you have to set the problem like this, and you have to run the simulation, and then that's it will give you the solution. And we have different configurations as well. Like you can run it in full configuration, or you can run in a random sampling, because if we have very large clauses for very large numbers, if we have a lot of possible combinations, so simulating all of them will take a lot of time. So what we are doing is, you can either have a full simulation, or you can have just a random sampling in order to reduce that time to find the solution faster. And you can also look at the source code, and you can modify the code as you feel like. So that's it. This is our project, and feel free to reach out. So these are the state of the art. These are the state of the art work which have been done on the dynamic computing so far. And so thank you, and you can reach out to me, either me Mohammed, this is my GitHub. You can either reach out to me here, or you can either reach out to Muhammad Sami Amjad. So that's it. Thank you so much.